YouTube. What is up? What is up? What is up? What is up? Peace in, everybody. So we're up to what? Part 21 of our cover-to-cover review of this handbook. It's a lot of hours put into here, guys. So we're at the end of January. Some of you guys are taking the grade 9 SHSAT tomorrow. So we're going to go over some more of those problems. If you guys haven't gotten a look yet, let me pop out 2 links before we start up on the problems. Definitely go to my site and look at SHSAT 9, which has some references to a bunch of math already. Hello there, Mr. Cucumber. This is some SHSAT 9 stuff. I'm also going to pop you guys out a link to some of the ELA stuff, because it really hits home on what the main idea is. Also, if you guys have not looked at the ELA section of the earlier versions of the same review here, you guys should do that. All right. So I have what I call my ELA starter kit, which really hits home about main idea and why it's important and how it's essential to all of the reading comprehension and the Rev A, Rev B section, and even your reading of the math problems. Okay, so go check out those links. I know you guys don't have much time, but some of you still have a couple of weeks. I think the last tomorrow, next Sunday, and Wednesday, February 10th. And I have a feeling the DOE is going to add one more date just for a bonus of some sort. All right, some people start to trickle in. Hello, welcome. So we're just going to start pounding out. I'm going to try to get the remaining problems done in one swoop. If not, we might break it in half or just leave off where we're at, okay? Yeah, best of luck and best of skill. Let's see how my throat lasts through this and so on. So you should see this on the screen. Oh yeah, let me make sure we're live here. So I'm Greg from GregsTutoringNYC. Welcome everybody. I do a lot of standardized testing prep as well as homework prep and stuff like that as well. Just make sure the stream's coming on my phone and I can look at the chat from there. Because sometimes the browser crashes and so on. No, it's saying I'm not live. Okay, wait, here we go. I don't hear anything. Let me see. Okay, no, we're good. All right, so let's jump into this. Again, we'll go as usual. If you guys want to guess the answers, please go ahead and do so. If you're catching this on the replay, you can certainly pause, try to get the answer, and then see how we rip it apart online here. And if you have any questions about each problem as we're going along with it, definitely feel free to toss it out. If you have general problems as well, general questions, general concerns, whether it's about anything about the SHSAT, just throw it out there, and either I'll decide live whether to cover it or cover it at the very end. All right, so let's just jump into question number 1. Oh, let me get this going so I can do the tablet. I'm trying to remember too. I think there's one question here that has an errata error. If we get to it, we get to it. I might be remembering this incorrectly though. I believe one of these questions had something wrong with them, either in the answer choice or in the question itself. Okay, so the side length of a certain square microchip. So we know we're starting out with the square. Expressed in scientific notation is 1.2 times 10 to the minus 3. So that's the length of the side, okay? Which is true of all of them. They're all that same length, okay? If the area of the microchip is expressed in scientific notation as B equals B times 10 to the A square meters, what is the value of A? All right, so this is just plain old Jane multiplication. So the area of a square is equal to the side squared. So in our case, that's 1.2 times 10 to the minus 3. that whole thing squared, right? We have to honor PEMDAS. We just can't square the 10. We have to square the 1.2 as well. So there's a couple ways to write this. We could actually do it as squared here and just do it out. Or we could have 1.2 times 10 to the minus 3 times 1.2 times 10 to the minus 3. What I like to do is when I have an exponent problem in the form that they're giving here, like b times 10 to the a, and then if there was another one, say times c times 10 to the e or whatever, I like to multiply the b and c first, and then the powers of 10 separately, okay? So that means what we're going to get is effectively 1.2 times 1.2 is one part, and then 10 to the minus 3 times 10 to the minus 3, okay? So you should all know your perfect squares. They always come up in this test. So 12 times 12 is 144. And we're going to have two decimal places because there's 1.2 and 1.2 minus 6. So we have 10 to the minus 6, okay? So they're asking what is A? A is the minus 6, okay? So that's all they're looking for there. So this is a 2-second problem. It's really not that involved. It took me a lot longer to explain it than actually just do it, all right? All right, does anybody have any questions about that? One second, I lost my tab here. Okay, question number 2 is I'm going to look at the table first. I have a SOAP survey. They're doing some sort of poll on SOAP. Okay, something uses L, something uses M, something doesn't use L, something doesn't use M. Okay, I normally try to get just an assessment, like about how much data is going on here. There's a few hundred. I have 250, 260, so that's 500. I have 150 and 130, so that's another 300. I have about 800 numbers, 800 samples here, if you will. Okay, and I notice it's just separated into 2 categories. Uses L, don't uses L. Uses M, doesn't use M. Okay, so I can ask myself questions about this. How many people don't use L or M? That's this number here, 136. Okay, how many use L and M? That's the 148. Okay, so again, this is all happening in seconds when you analyze this. Okay, now that I've gotten as much as I can out of the illustration, I'm going to come back to the words. Okay, if you jump here, remember you still have to go and read the top. So they often do this in 2 styles. There's either an illustration and a bunch of words, or they do words, illustration, words. Okay, usually the words on the top are not as important, but it's telling us something like this 800 people here. Okay, so I should be able to come back here and verify that those numbers make sense. Now there's a bunch of totals that you can get out of this. We don't know which ones we should be doing or not, but let's just try to let's add up going up and down. So we have 8 plus 4 is 12. Carry the 1. We have 6, 10, 11. Carry the 1. We get 4, 1, 2 if we were to write a total here. Okay, and then we can do that here. We get 8. 5 and 3 is 8. And then 2 and 1 is 3. So we get 388. So what we can add here is another total column. Okay, and this total here, they told us was 800. So is 412 plus 388 equal to 800? 4780, yes it is, okay? So we're able to check that. What we don't know is did I really need to do that, and did I really need to do that? But we're just trying to make sense of this here. So on the actual test, I am not suggesting that you actually do that. Anyway, if we add up horizontally, 148 plus 252, we get 390, we get 400, which means this should also equal 400. So we get 2, 3, 60, 90, yep it is, okay? So all the numbers check out. We're not sure what we're supposed to be using here, though, because the only thing we did was analyze the illustration, and we got past this here, okay? So it's telling us about people use L and M, and there's this 800, okay? So based on the results of those who do not use L, X% use M. What is the value of X? Expressed as a whole number. Okay, so what does that mean? How does that refer back to anything? Of those who do not use SOAP L, so they're looking at these numbers here, this line here. Okay, they're not looking at this line. This doesn't come into play for the question. So that's why I was saying we don't know what to add up in total here. So a slight waste to have total that line. So on the real test, you wouldn't necessarily have done that. Yes, good luck, everybody. So what they're trying to ask you is, based on the results of those who do not use L, X% use M. Well, that was this column here. So that's the 264. Okay. Of those who do not use L, so of those who do not use L, there's 400 of them. Okay, there's not 800 anymore. It's only of those who use L, right? So they're not looking for 264 over 800. That's not what's being looked for here. Okay, it's 264 over 400, right? That's what it's saying, based on the results of those who do not use L. So that's only this line here. Of those who do not use L is 400. Okay. X% of the 400, which is what I have circled right here, is 264. So all we have to do at this point is make 264 into 400. So this is easy math. So what we don't really want to do is do 400 divided into 264. That's going to take us too long. Whoops, what just happened there? I clicked a button on the pen. Wait a second. We lost the page. Wait, there we go. Okay, so we don't want to do this. All we can do is set up a proportion that we have X over 100. We see that this is 400, and this is a magnitude of 4 less. So really all we have to do is divide 4 into here, right? So 4 into that is going to be 6. We got 24 with a remainder of 2, and 4 goes into that, 6 again. So the answer turns out to be 66. So it's 66%. Okay, does that make sense? That 264 out of 400 is about 60-something percent? Yeah, it does, okay? Right, we can just divide both by 4. And then at the grand scheme of everything, it would have turned out if we did 264 over 800, that would have turned out to be 33%. Because this is 264 over 400, the other is 264 over 800 that we did here. So that 33% might be the answer a lot of you probably calculated. That would have been wrong, okay? All right? And by the way, you could have done that the same way, assuming it was the answer. So if we had 264 over 800, we're just going to target this here, so we could divide this into 8, right? 8 goes into 26 3 times with 2 left over, and then we get 8 into 24 3 times. So we would have got 33 there, okay? All right, so you guys good with this? It's looking at the illustration, going back to the words, trying to make sense of the magnitude of the numbers, trying to kind of calculate it in your head. Oh, that was about, it's greater than 50%. It's not 75%, right? Because then it would have been 300. So 66 sounds about right, okay? And then feed it back in, see if it makes sense. Okay, so that's number 2. Okay, 3. The values in the table represent the function. What makes a linear functional? What makes the function linear? So this is coded language for it's the equation of a line. That's all that means. If it's a linear function, you guys are used to input-output tables. This is your input. This is your output. Okay. So if we get -4 for x, then we should be getting 2 for y, and so on. All right. So there's a couple ways to kind of solve this. Depends how you look at it. All right. We can almost kind of fill in a table. You know what I'm going to do? I'm going to go to solve 6 first, because I'm going to use the space underneath there, I think. So let's skip to 6 for 1 second, and we'll come right back to 3. Which expression represents a rational number? So this question is strictly a terminology question. The SHSAT doesn't really use or ask that a lot of times, but here we have a case where it does. Okay, so a rational number basically means it can be expressed as a fraction. So E is clearly a fraction, so E would be the choice just straight up. If you know what a rational number is, this is just a straight up easy peasy answer. Okay. How do we know if we're ready for the SHSAT? Oh man, you're never ready for it. You know what? There's always another problem, always another topic, always another concept. I'm pretty sure from the feedback I've gotten from you, Oreo, and I don't know a lot about all you guys. I think you're doing fairly well. Just pace it out. You know also from the feedback you're getting on your practice tests as well. So just in case, let's say you didn't know what a rational number is. By virtue of them giving pi, most of you know that's 3.14, and then it repeats to infinity. It goes on forever. So many of you could probably figure out that the square root of 3 is like 1.7, I believe it is, and then it probably goes on. Does it repeat? How can you figure that out? Okay, and then the square root of 83 is going to be like 9 point something, because 9 times 9 is 81. So this is going to be 9 point something here. That might repeat as well. Okay, so G and H are kind of in the same category, that you're not sure they repeat, but you know they have a bunch of decimals on them. But you know pi for certain, if you learned anything about pi, you should just know it repeats forever. All right? So these 3 seem to be lumped into the same category. So I'm saying this from the perspective that if you're going to do the process of elimination, if you didn't really know what a rational number was anymore, right? These kind of are lumped in together. If anything else, G and H is lumped together, and then by just you might as well include pi into that. Okay. And the kind of the freak one is E. E is the unusual answer, because it's just expressed as a fraction. None of the others are a whole number; they're all square roots. So that would be how you would kind of meander through this if you did know what a rational number was. Okay. Also, Oreo, generally you want to be getting minimum 75% of the questions right, and preferably about 85% of the questions right. But once you break past 65, you're cool. And if you can work your way up to 75, that's a pretty reasonable thing to do. Okay. So going back to 3, there's a couple ways to approach 3. One is just to look at it in pertaining to the slope, right? So it's the rise over the run. Okay. So we're going to use these 2 points. Let's just call them A and B. And then we do that for that. But it has to match, it has to be in the same XY pair, okay, minus the other X point, okay? So in our case, or in the case of this input-output table right here, okay, we're going to just do -1, right, -2 over -1 minus a -4, okay? So that's equal to -3 over -1 plus 4, okay, which is equal to -3 over 3, and that's equal to -1. So that's our slope, okay? So if we were to feed it back into the equation, we're going to get y equals -1 x plus b, okay? Or we could just say it's equal to minus x plus b, all right? So that's all that's going on there. You're using this here, okay? Okay. What we can then do is stick one of the points into it. Let's take point A, okay, and figure out what B is. All right? So if we have y equals minus x plus b, if we use the points here, that means we have 2 equals minus -4 plus b, okay? And then 2 equals plus 4 plus b. We subtract 4 from both sides, and we get b is equal to -2. So that means our equation is y equals minus x minus 2, okay? So now we can come along here and take the last point, which is the one we're trying to do. Y is r, so r is equal to minus x, x is 3 here. So we're going to have -3 minus 2, and that's equal to -5. Okay, and that's our answer, -5. Okay, that's a kind of long-winded way to solve this. Okay, we could have also just picked up on the slope and figured it out from there. If the slope is the same, we don't really need to worry about finding the b here. Okay, so we already found the slope over here before, which was -1. Okay, the slope was -1. So that means any calculations we do here, we should still get the -1. So if you go -1 -2 over -1 plus 4, right? We get -3 over 3, and that's equal to -1. So we kind of need to do that same thing with the last 2 points then. So we can use point C versus B or C versus A. Okay, it doesn't matter which one we use as long as we can get there. All right, so if we use the rise over the run, we get R minus -1 over, what is that, 3? 3 minus -3, okay? So we get R plus 1 over, is that over 6? No, I wrote the wrong thing here. This is 1. So that'd be 3 plus 1 over 4. Okay, we know the slope already is -1. So if we just multiply both sides by 4, times 4 here, that cancels out, times 4 here, that is equal to -4. Okay, so that means we have R plus 1. We subtract 1 from both sides, that cancels out, and then R is equal to -5, which is what we got earlier. Okay. So that's two different ways to do this kind of a problem. Please subscribe, guys. I'm still going to be doing more of these. Please like as well, just because it's the right thing to do. All right, so is there any questions about the first three problems? And as well, number 6? Okay, so this is going to be using the distance formula. So what we want to do is, you know what? Let me load up a graph paper, especially since my handwriting is so atrocious. Give me 1 second. Notice I should have printed out the page. All right, I can flip back and forth here. So we don't need to visualize this, but I think it's worth you guys visualizing it. So we're kind of taking a sidebar for a second. Or not. It doesn't seem to be letting me make additions to this. Let me load that one more time. Meantime, if anybody has any questions, please don't hesitate to ask. No, it's not letting me do that. Let me try to pick up a different piece of graph paper. Okay, that one looks like it's good. All right, so if you go back to this, let me get rid of that one. That's no good. 320 and 11.5. Those are our 2 points. So if this is our x-axis and this is the y, okay, so 3 is here. Let's just do it in 5s. That's 5. 1, 2, 3, 4, 5. That's 10. That's 5. That's 10. Whoops, that's 10. So totals we had 320. So we got to do some more. 1, 2, 3, 4, 5. That's 15. 1, 2, 3, 4, 5. It looks like 20 is about right there. I don't need to make this totally exact. So we have 320 is here. And the other point was what? The other point was 11.5. So that's right there. So basically what we're going to be doing is dropping this down here until over there and coming over here. So if you guys can see, this is a right triangle, okay? So what we're trying to do is figure out the legs of the triangle. This is A, this is B, and this will be C, the hypotenuse, right? Okay. So what we're trying to do is get the difference between here, and also the difference between here and here, okay? So if we come back to the problem, what we're just going to do is figure out what those differences are. So the difference between the y is going to be, and we don't care, we only care about its absolute value. In this case, we're not comparing about it. So we have 20 minus 5, we get 15, and the difference between the x's is 11 minus 3, and that gives us 8. We could have done it in the reverse order and got a minus 15 and a minus 5. We're taking the absolute value of them, okay? So that means when we look at this here, this is 8, okay? That's 8, and that's 15, okay? So if that's 8 and 15, the question is, what is this? This is 17, you should know that, okay? So you can do your Pythagorean Theorem, which is indirectly what the distance formula really is. Wait, Adobe just popped something up here. Adobe's freaking out on me. So we're going to have c squared equals a squared plus b squared, okay? And so you're going to get the 8 squared is 64. The 15 squared, again, remember you guys need to know all these. You get 225, right? And you're going to get, when you add those up, you're going to get 289. And that should give you the 17. Okay, so not only should you know 17 times 17, but you should also know the square root of 289. Okay, and that's what you get it. You should also know your Pythagorean triples. Okay, let's bring that up a little bit here. So we covered this a little yesterday. You should know, for instance, your 3, 4, 5 right triangle, right? That's this kind of a thing. If that's 3 and that's 4, then that's 5. So these come up a lot in a lot of cases. So you should know 3, 4, 5. You should know 5, 12, 13. You should know 7, 24, 25, right? You should know the one we just had now, which is 8, 15, 17. Okay? And then there's 2 9 ones. You should know 9, 12, and 15. And also 9, 40, and 41, okay? There's 2 special right triangles, which is your 45, 45, 90, okay? That's 1, 1, the square root of 2, okay? You should also know about your 30, 60, 90 triangle, okay? Which gives you 1, the square root of 3, 2. So you should know 1 of them, 2 of them, 3 of them, 4 of them, 5, 6, 7, and 8. So while you're memorizing your formulas, you should memorize these 8, and also be aware that, for instance, if you got a right triangle that may have had a distance let's say this was 14 and this was 48, you should know immediately this is 50, because then it'll be a multiple of 2 of this one here. All right, guys? So be cautious with that. Be aware of that. All right, so that was number 4. Okay, number 5, let me get rid of some of this clutter here, because I wrote in that space there. Okay, so we're going to do the distributive property on this one. So we're going to get 3x minus 12. This we're just going to copy down. Plus 4x equals 4 minus x, and we're going to do the distributive property there. So plus 48 plus 8x, okay? So we're going to combine like terms. 3x and 4x is 7x, okay? We have minus 12, so minus 12. We get 4 and 48 is 52, okay? And then we have minus x and 8x, so we get 7x, okay? So let me rewrite this so it's clear. This says 7x minus 12 equals 52 plus 7x. So if we combine like terms, we combine like terms across within the equal sign. Now if we combine them across, if we do something like this, that cancels out, and it cancels out here, and we end up with minus 12 equals 52. Can no do. The answer here is C, and I had loaded, just to show you guys, there's a problem in the handbook. There's an errata entry. While that's loading, somebody's asking a question here. The screen is still on the answer sheet. Right now it is still as well. All right, is it showing the right thing now? Yes, it is. Oh, man. I'm not sure since what problem was that the case. I did the test the 27th. I was good and kind of hard, but thank you for tips. Hopefully I passed for the school I want. Yeah, I hope so as well. Remember, just enjoy the journey too. If you get into a school, that's a bonus. Just do this for the joy of it. All right, are you guys seeing the right thing now? Anyway, I'm gonna bring the answers back up again because there was a problem in the handbook pertaining to that. So what might make sense to do for you guys on the replay is to do 2 tabs of this so that when it gets out of sync, instead of me going back and answering the questions, you can just kind of line up the conversation with the audio on one and the visual on the other, and then catch it back up again. Does that make sense, people? All right. So if we go here, right, it says for number 5 here that the answer is D. The answer is not D. Am I at the right question here? Okay, guys. So, oh, I see what happened. Adobe broke out the tab for some reason. I don't know why it did that. All right, let me get rid of that off my screen. Always wonderful technical experiences. Brooklyn Tech. Yeah, I went to Brooklyn Tech as well as one of my kids. It's a great school. They're all great schools though. There's also great schools that are not specialized high schools. I had the ninth grade Bobby Tarek practice book, and the math is really hard for some of it. Nothing I've learned will be the same for the real test. Yet Bobby is normally a little harder. There's also errors in his text, unfortunately. It's getting me worried because the practice book is really difficult. Like the formulas and explanations is confusing. Yeah, that definitely goes overboard. So be careful with that text, guys. That book is usually more hard, but not all the concepts from the book are on the test. Well, there are some years. He does have good examples. I'll give him credit for that. There's really nothing wrong with the examples per se, except for a bunch of the typos and so on. So, all right, 1 second, guys. I think the Adobe crashed before. That's what happened. So I'm going to exit the Adobe and reload it so that we got a straight situation going on here. So give this 1 second. If anybody has any questions in the meantime, please ask them. Well, Cassie, did you use any other books? You should have. Remember, all the grade 8 stuff is still appropriate. So there's still that. And you also have the handbooks to go by. There's about 9 practice tests over all the years, because some of them are the same test over and over. So you have that as well to go by. So, and the fact that you realize that Tarek might be harder than it needs to be is a good thing. Remember, too, you want to get baseline and go above a baseline. Tarek goes a little above baseline, so you just want to be careful with that. But all right, I got Adobe to exit. I'm going to reload it back. Give me 1 second, people. But it can be tough because he's more tending towards like SAT questions and so on, and a little more clever than they need to be. So give me 1 second. I'll answer that while this is still trying to load. Is the handbook showing you guys the screen now? You should see the first page right now. In the meantime, let me give you some pages to look at while that's loading up probably. Da di da di da. All right, I'm posting a link to some math topics. Again, the next one's going to be a PDF with some of the same info. Okay, the next one is going to be a link to about formulas. Here's a link to a PDF for that too. Some geometry things, as well as the geometry I went over yesterday. That wasn't necessarily grade 9 specific, but it was still appropriate to the conversation. So look at part 20 of this series. Part 20 of this, because I think we're in part 21 right now, okay? I use a lot of grade 8 practice books. I use the NYC Handbook and the two tutors. Well, remember, Cassie, most of the test is grade 8. The grade 9 stuff is a superset. So maybe 25 to 40% is the only additions, and a lot of it's going to be the same. So I understand the whole ELA is the same. I keep getting conflicting data about that, but you know, you just got to roll with it. All right, so let's see what we got going on here. All right, you guys should see the handbook now. Let me go back into the section that has the grade 9 stuff. Where is that? Right here. Okay, we just did 4, we did 5, we did 6. Okay, so we should be up to 7 now. All right, so this is normal exponent. Understanding your exponents. There's a couple concepts here. One concept is basically a base to a minus exponent. Okay. So there's a few ways we can solve this. One is to write it longhand, that we have 6 to the minus 10 divided by 6 squared, right? That's really what that's saying. So when we do division, right, what are we going to do there, guys? We're going to subtract it. So that means we get 6 to the minus 12, right? Okay. Okay. None of these answers is 6 to the minus 12. But we know that a base to the minus exponent is equal to 1 over base to the positive exponent. So that means this is the same as 1 over 6 to the positive 12, okay, which turns out to be B. Okay, we could have done this a few other ways. If I have A times B, I could, and B is a fraction. So if I have A times 1 over B, that's the same as A over 1 times 1 over B. Why am I showing you this? Because this is the same as 6 to the minus 10th over 1 times 1 over 6 squared. Okay? So if this is true here, then we can rewrite the 6 to the minus 10 as 1 over 6 to the 10th. And then we have 1 over 6 to the 10 times 1 over 6 squared. And this is just exponent addition when we're multiplying, because now we have 1 over 6 to the 10th times 6 squared, and that's equal 1 over 6 to the 12th, right? So there's a few ways we can approach this, depending on which rules you know or not. Basically, the 9th grade test is everything you learn from grade 8. Theoretically, that's the way it's supposed to be. Theoretically, the SHSAT 8, theoretically, SHSAT 8 is supposed to be from pre-K to grade 7, okay? theoretically, SHSAT 9 is supposed to be from pre-K through grade 8, okay? Now, both of them add stuff. So there's grade 7 plus this, plus that, grade 8 plus this, plus that. All right, so really what it's kind of adding is polynomials, okay, simultaneous equations, stuff like that. But the truth of the matter is sometimes some of that is also on this test. So it's a mixed bag. But yeah, it's adding a whole bunch of tweaks on top of it. So, but theoretically, the SHSAT 8 is only up to grade 7, even though we know it goes past that, okay? Okay, number 8. Okay, which best represents a linear function? So when we did question number, which question was that? The one we just did. When we did 4, because 4 involves a linear equation. When we did 3. So it's really the same kind of question that they're asking us in different shapes and forms. Where is that question there? So what we kind of want to look for is a consistent slope, okay? And we could just figure that out for them each. So the difference in the y here is we're going to get between here and here, right? We're going to get -2 over, because we're going to get 3 minus 5, and we're going to get -1 minus -3, which is 1 plus 3, or 4. So we're going to get -2 over 4, right? And we're going to get, the question is, do we, so the slope has to be consistent if it's a linear function in that case, right? So if we go backwards here, we're going to get -2, but this is only -2. So E is not a linear function. Ignore the word best, because it's either your linear function or it's not a linear function, all right? So you have to make sure that's what you're doing. It goes past 8, but that's basically what it's saying. And it's talking about the Common Core base classes. It's not talking about grade 8 students who are taking the Regents algebra class. It's not talking about that, okay? Okay, we're going to do the same thing here. So we have -3 over -1 minus -2. So that doesn't seem to work, because this is only off by 1 here then. 3, right, this is 1 and this is 3 and this is 1, 1. So the slope here doesn't work. So that's no good. Okay, G, we get a difference of 5 here and a difference of 1 there. So the slope there is going to be 5 or -5. Let me actually do it. So we're going to get -12 minus -17. These are nastier numbers. And -3 minus -4. So this is equal to -12 plus 17. And this is -3 plus 4. So we get what? We get 5 over 1. So the slope there is 5. Okay, so do we get the same slope here? We get a difference here of 20, and we get a difference here of what, 4? Okay, so G seems to be the answer. Let's just check it with H. And I know H is no good because these two are the same. And if these two are the same, then this would have to be 2. So we can also apply the slope and see that's wrong, but H is no good. So for that reason, G is the case there, okay? How can we practice for difficult poems and passages? I would go back and look at my live streams. I just went through examples for you guys just for that, to show you really how to rip it to shreds. You have to rip it to shreds. If you don't rip it to shreds, you're not going to get it done. The questions are too laser focused. They're not vague, where they're asking like, just some high level thing. They're really zeroing in on stuff. And remember, it's more about the questions and answers as much as it is about the passage. But I went through this time with the cover-to-cover review. I actually went through and read the passages, put the notes on you, pointed out you guys what you should be looking for, how you should be thinking, how you should be approaching all the different kind of question types and things like that. Okay. I know it's a lot of video to watch. If there was 6 parts of it or something, and you have to watch all those videos, so that's about 8 hours of videos probably, just to kind of grok that. But it's worth it, because otherwise, what you guys are doing is you're just trying to do passage after passage after passage after passage after passage, and question after question after question after question, and you don't know what you're looking for. So just one of the smartest things you could do is actually go see how I'm ripping it apart. What I'm saying is important versus not important. That could be some of the best 5 or 6 hours that you're ever going to spend. And it's going to apply to everything else for the rest of your life, too. This is about your perception of the questions, particularly the standardized tests. So when you get to take the SAT or some other high-stakes kind of thing that's looking for the same kind of thing, then you'll have a good heads up on it, okay? I improved my grammar, and now I have my ELA to improve on as well. Yeah, and part of the grammar is actually connected, like the revision B and so on is also some of the same skills need to be required. Okay, so number 9 is another scientific notation question, because number 1 was as well, right? Where we had the thing about the microchip, where it was using this here and that there. Okay, so number 9 was it? Where are we here? Yeah. So it's trying to compare 6 times 10 to the minus 7 meters versus 3 times 10 to the 8th meters. So which statement compares to correctly? So they're trying to get a thing of magnitude here. That's really what's going on here. So what I like to do is kind of line up the two numbers. We use the space over there. All right, let me try to squish it in this little space right here. So my two numbers are 6 times 10 to the minus 7 versus 3 times 10 to the minus 8. So what I want to do is get both of these exponents to be the same, okay? So let's take a little sidebar over here. If I have A times B equals C, okay? If I was to divide B by 2, for C to still be the answer, I would have to multiply A by 2. Right? Did you follow that? If I have A times B equals C, if I divided B by 2, I would have to multiply A by 2 for C to still be the answer. Right? Let me kind of write that out longhand over here. So if I have A times B equals C, and I'm claiming if I multiplied A by 2 and divided B by 2, it would still be C. Yeah, that works. Look, that cancels out that. And I'm left back with the original equation. All right? So if, instead of 2, I use the power of 10. So if I said 10 times A times B over 10 equals C, those still cancel out. Okay? So why am I talking about this? Because I'm going to try to bring the top one equal to a 10 minus 8. So I'm going to leave the bottom one alone. I have 3 times 10 to the minus 8. And I'm going to force the top one into be a 10 to the minus 8. So to bring it from a 10 minus 7 to a minus 8, what did I have to do there? I actually divided it by 10. So 10 to the minus 7 divided by 10 is 10 to the minus 8. So if I divided the 10 here, I have to multiply this by 10. So I'm going to get 60 times 10 to the minus 8. See how I did that? So now they're both 10 to the minus 8s. All I have to do is compare the 60 and the 3 now. Okay? So this was A, cell A, and this was cell B. So that means that it's 20 times the diameter. Right? So now it's easy peasy. The other way was to actually try to divide with weird fractions and stuff. You could have wrote this one here is like 0.00003 or whatever, And the other one, that gets too messy. All right, so that's that one. Number 10, I'm going to look at my data here. Look at my screen first. I have an illustration. It's about soccer data. That's pretty generic. I don't know what that means. There's players' names here. There's the number of seasons played and the goals scored. What else can I figure out? I can do totals here. Okay. There's about 10, there's about 14 things here, and there's about 25 or so here. I think there's less than 25. I'm just trying to get a magnitude of what's going on here, right? I also noticed that if there was a relationship, that's greater than that, that's greater than that, that's greater than that, and that's greater than that. Okay? So I'm not sure what else to do with the table, so I'm going to look at the words finally. The data in the table shows the number of seasons some players played on a soccer team. So that's here. That's cool. Versus the number of goals they scored, which is here. So that's cool too. Which conclusion is supported by the data? So let's shrink this down an iota. Okay. There are multiple outliers in the data set. I'm not convinced that's necessarily true. So let's try to do a quick mock-up. Let's see, it goes to 10. So let's say this is 10. This is 5. That's 10. That's 5. That's 10. That's 5, and that's 10. Okay. So it's telling us the point is 3, 5. That's 1 point. Another point is 6, 10. So that's about here. The other point is 4, 6. That's about here. And the other point is 1, 3. So I'm going to say that's about here. So if we do a line at best fit, that seems to be here. Okay. So I don't think it's E. There doesn't seem to be any outliers here. There is a positive association between the number of seasons played. So this is the seasons played, and this is the goals scored. Okay. There's a positive association. So first of all, the slope is positive. It's not negative, right? A negative slope goes that way. It's not that. It's definitely positive. There was a positive association between the seasons played. So as seasons played increase, the goals scored increase. Yep, that's definitely the way this is going. Okay, so it seems to be F. Let's just rule out the other two. There was a negative association. No, so we just proved the opposite. And there was no association. No, there seems to be one. There seems to be an association. So that one's fairly reasonable to get F out of. Okay, 11 looks to be like a simple algebra problem. A few of you are probably going to jump right into this and do the distributive property and get 0.25 y plus 0.25 times 8, okay, equals 15. That starts getting ugly, but let's solve it anyway. 0.25 y, this times this is 4, right? Plus 4 equals 15, all right? No, sorry, that's 2. See, that's the problem with that. That's 2. Okay. We're going to subtract 2 from both sides. So we're going to get 0.25y equals 13, if I did that right. And some of you are actually now going to go and do 25 times 13. Okay. Because you're going to divide it by. Because you're going to divide both sides by 0.25. Okay, and when you do that, you get 52. Okay, that cancels out. Okay, there was a simple way to do it, was just to notice from the get-go that 0.25 is equal to a quarter. So it's as if we had 1/4 of y plus 8 equals 15. Okay, which is the same as y plus 8 over 4 equals 15. So if the goal is to get y by itself, we're going to multiply both sides by 4. We get y plus 8 equals 60. And then we subtract 8 from both sides. Y equals 52. So it was quicker just to multiply this by 4. So this is the yin-yang here that we have to kind of figure through. Okay? It's almost like a chess move. If you can try to foresee that next step or two, even if you don't know what the exact calculation is, that, oh, if I just multiply by 4, this becomes faster and easier, and probably more accurate too, because your efficiency, you might make a mistake when you do this division over here. All right, so you need to be careful with that. Is everybody good on that one? Okay, 12. Okay, so what is the volume? So somebody was asking before about grade 9 stuff. This is almost always a grade 9 question, where it's dealing with the volume of a beach ball, which means it's the volume of a sphere, right? Okay, so you must know your formulas. It's 4/3 pi r cubed, not squared. Not squared, cubed. Okay, so if the diameter is 24, then the radius is equal to 12. So we have 4/3 times pi, and then we have 12 times 12 times 12. That's 144. Okay. 3 goes into here. This 12, 4 times. So we end up with 144 times 16 pi. Okay. It can't be E. It can't be F, because this number is too large already. It can't be G. Okay. And then we can actually now go and prove that it is. What do we get? 6 times 4 is 24, 2, 24, 28, 2, 8, and then we get 4, 4, 1, we get 4, wait, did I do something wrong there? This was a 6, sorry. That's 0, 1, 9 plus 4 is 13, 1, so we get 2, 3, 0, 4 pi, okay? So we were able to prove that as well, okay? So the key was getting this. This was probably the nastiest math of the whole thing, which is to do this, okay? As much as I like to say I don't need to actually do the calculation because I knew it was h at that point, because the magnitude of this was too large, it's still worth doing it, right, just to be sure. And then go back to the problem and see, does it make sense? Was I supposed to use 12? Should I have used 24? Was I supposed to use some other number? Is this really the formula, right? There's too much to figure out here still, even on a simple question like this. But again, it shows why, if you're getting over 40 questions right, would you throw this away by not having memorized the formula? All right? And finally, the last question. So the last question is complicated in a way, but it's also easy at the same time. It's easy to look at 13 and think, wait, it's asking me about integers. If that's a whole number integer and that's a whole number integer, then the only choices in here is like 5.6, 5.9, stuff like that. So none of these can be the choice, and therefore the answer is A. But that's not what it's asking. So that's wrong. Okay? That's wrong. It's asking, what is the square root of n? Okay? It's not asking how many integers are between 5 and 6. It's saying how many n's will satisfy that square root criteria. And in a way, the problem is if we square the whole thing. In a way, that's what we're doing. So we're trying to look for a number between that, okay? That's really what we're looking for. How many integers satisfy the condition that the square root of n is between 5 and 6? All right? So what they're asking for instance, the square root of 30, the square root of 35, okay, the square root of 26, right? How many of those integers? That's the integer they're talking about there. Not between 5 and 6, but between these two ranges here. So how many integers satisfy that? Well, it has to be, it can include 25 and 36. So we have 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. That's 10 numbers, right? Because we're talking about from 26 to 35, okay? So we can do 30, we can use our fingers or actually do the subtraction to get 9. And remember, you always have to add one more. So that gives us 10 there, all right? And there you have it, guys. All right, does anybody have any other questions? Otherwise, we're done with the review. I might do some more of these over the next few days because there's some of you who are still going to be taking the SHSAT. There's still all the Form B questions. What I might do is look through it and hunt and pick out some of them, especially like a poetry passage from Form B. Brian, what date are you taking your test? Is it tomorrow? Because if it's on the next Sunday, then I can do that during the week at some point, especially a poetry passage on the Form B. In fact, let me look real quick. I can't remember, even though I've done it a few times. Let's see what Form B has. Also, if you guys go to my ELA page, let me just hold on 1 second too, because that also has some poetry passages I go over from past information. So if you check out my so-called ELA starter kit, I have some poetry videos specifically about the SHSAT, as well as I also have general ones too. All right, so let me go back and see if this. I'm positive there's a poem in this, but let's see. Niagara Falls. Is it the fireworks one? I'm trying to remember here. I've done so many passages, it's all a blur to me. All right, it's this one here. So I can certainly go over that. All right, anybody have any other questions? Otherwise, we're done for the day. And remember, there was a part where the display wasn't showing. So if you put the screen, you played the live stream in 2 videos, okay? Then what you can do is pause to where it doesn't display the other window anymore, and go in the second window along the timeline to when I finally show that on the screen. And then if you hit play, you can follow along with what I put on my notes there, what was going on those 2 questions, all right? All right, guys, good luck and good skill. Remember to just breathe, remain calm, and it'll all work out. All right, and enjoy your weekend, people. It's freezing. Peace out, everybody.